Hi, everyone. Welcome to day 6. We're going to be going over linear functions today uh, for our SAT practice. Some of this is going to be review, but we're going to look at how linear functions are in many different forms and how we can interpret the data from tables. We're also going to go over a little bit of Desmos activity work as well. So to start off, we're going to talk about what a linear function is, slope-intercept form, and tables. A linear function has x and y variables in it. This is a little fuzzy to see here, unfortunately, but you can still see it says 3x plus 4y is 17. That's a linear function. We know it's linear because there's no x squareds and there's no y squareds. This second one is not a linear function because we have an x squared there. So all of these linear functions are going to create a straight line. It doesn't matter if we write it like this in this form here, 3x plus 4y is 17. It doesn't matter if we write it like that, or if we just solve it for 1y. If we write it in the calculator, it's going to give us the same answer no matter what. So let me show you how we would solve this for what 1y is. So this is 3x plus 4y equals 17. We're going to subtract 3x from both sides. We get 4y equals negative 3x plus 17. Divide by 4 on both sides, and we get negative 3/4 x plus 17 over 4. So that's how we would solve this equation for 1y. And hopefully that's a bit of review for you, but if it's not, that's okay. And that makes the same line on the graph. We say it's linear because it goes in a straight line continuously. Slope-intercept form, we can write it f of x equals mx plus b, or we can write y equals mx plus b. Either way is perfectly acceptable. In a real-world situation, the slope is changing, and the y-intercept is our fixed value. So that means that m is our slope, and that's what tells us how steep the line is. If it's steep or if it's really steep like that, our slope's going to be a bigger number. Slope is usually written as a fraction or a whole number. If it's a whole number, you can always write it as a fraction. So if m equals 4, you can write it as m equals 4 over 1. The y-intercept is b, and b is where it crosses the y-axis. So we can think of it as our starting point of our graph. So if we have our graph here and we have a line that looks something like this, b is going to be this point right here, and it's going to be 0 comma something. That something is what b is equal to. Let's look at a word problem example here where we have to identify slope and the y-intercept. So Sammy gets $4 for every chore she does, and she's already saved $3. Write an equation f of x that represents how much money Sammy will have after doing x chores. So she gets $4 for every chore that she does, and she's already saved $3. So the already saved $3, that's our starting amount. That's what b is going to equal. If we saw this on a graph, it would be like 1, 2, 3. There would be the $3 at 0 comma 3. And she gets $4 for every chore that she does. Well, that's going to be our slope. So m equals 4. Or we can write it like m equals 4 over 1. That's a little bit easier to understand, I think, because when we look at slope on the graph, the top number is how much we're going up by, our rise. It's up or down. And the bottom number is how much we're going over by, which is left or right. And so this is what our function is going to be. It's going to be 4x plus 3. So we're going up 4 spaces over 1 space. We're starting at 0, 3. This is a little bit tough to see that we're going up 4 and over 1, but that's okay. We can still see this is at 3 right here. So if we go up 4, That's going to put us at 7, just somewhere about there. And we're going to go over 1, and that's going to land us on the next part of our line. Now, you can just use Desmos for these, and you get Desmos on the SAT test. And so you could just type this directly into Desmos. You can write f of x, or you can write y, and you get the same exact line. And you can see the y-intercept is at 0, 3, and the slope is going up 4 over 1. It's a little easier to see on this. So going up 1, 2, 3, 4, and over 1, and that lands us right there on our line again. Let's look at another example. Raul has saved $23, has $23 saved, and he frequently buys candy for $2 per piece. Write a function that represents the amount of money Raul has left over after buying X pieces of candy. So again, we've got to identify our slope and our y-intercept. He saved $23. That's going to be B. That's our starting value where we're starting at. And he buys it for $2 per piece. When I first saw this problem, I thought, okay, well, that means M is 2. Because he's buying the candy, he's spending the money, and it's actually equal to -2. Because he's losing $2 every time that he buys a piece of candy, and he starts with $23. So if we go here, this is what our function is going to look like. Y equals 23 minus 2x. And 23 is our starting value. And we're going to go down 2 and over 1. Down 2, over 1. And the process is going to repeat itself. And so we get this linear function here. Now, when we have a table of values, that can help us to determine what the linear function or the line is. It can also help us predict what other values are. Like if we don't know the y coordinate, but we want to know the x coordinate of the line, we can figure that out. The best way to figure out a missing value on a table is the point slope form. And that is y minus y1 equals m times x minus x1. So our point slope form in this scenario, we have 2 points that they tell us. And we need these 2 points to figure out the y coordinate for when x equals 7. So in order to do this, we first have to figure out what the slope is. This x1 and this y1, that just means like this is x1 for this number 2. And this is, let me write it next to it, actually. It's probably a little easier. X1, and this is our Y1. And this, you can think of, that's just like point number 1. It's point number 1, but we call these X1, Y1. That's how we can determine what those points are. The next part, the next point on here is 5, 180. You can think of that as point number 2. So that's x1, it's x2, excuse me, and y2. So we really just need these 2 points so that we can figure out what m is. And m is the rise over the run. The rise is how much it goes up and down by, or how much the y is changing by. And we write change in y as a delta. It's a triangle for delta, and delta x for change in x. Our change in y is y2 minus y1. Our change in x is x2 minus x1. So y2 minus y1 is 180 minus 81. x2 minus x1 is 5 minus 2. x2 minus x1, 5 minus 2. And then we just check these on the calculator. This is, we get 99, 180 minus 81. And 5 minus 2 is 3. And we get a slope of 33. So m equals 33. Okay, so now that we know what our slope is, we're going to plug this in for m. Let me erase some of this stuff now, so we have maybe a little bit more room to write this down. I'm just going to erase this and erase all of this. All right, so now we're going to plug in what m is. We're also going to plug in y1 and x1. Y1 is 81. M is 33. X minus x1 is 2. And then we just use the distributive property. We multiply that, and we multiply that. We get y minus 81 equals 33x minus 66. And I know we're kind of getting into the words here. So I'm going to put the plus 81 and plus 81 on the left and the right, and we get y equals 33x 81 minus 66 plus 15. So that's going to be our equation for this line. Now we can go back to Desmos and we can just type in this equation into Desmos, 33x plus 15. When we type that in, you can write y equals as well and get the same thing. And the 15 is going to be our y-intercept. Now, if we go back to our question, it says, what is y when x is 7? And we can do one of two things. We can directly plug in 7 into our formula. We can say f of 7 equals 33 times 7 plus 15. 33 times 7 is 231 plus 15. And we get 246. So that's saying that this is 246. And we can check this as well. This m equals 33 means 33 over 1, which means that's our change in y. And this is our change in x. So that means when x changes by 1 space, y changes by 33 spaces. Here, x is changing by 2 spaces. So y should be changing by 66 spaces. And 180 plus 66 gives us 248. Or excuse me, 246. So that's one way you can do this. You can directly plug in 7 for the function. Now, if you're really fast on the computer, another way you can do this is go back to Desmos, type in the equation, click plus table, and we want to know what y is when x is 7. We just type 7 for x, and it should give us a value for y. Let's see here. That is not what we do. I was adding a new table. What we do is we click on this, we click on the settings gear, click on create table, and click on and type 7, and we'll get 246. What I had done earlier is if you press this plus button for a table, you can create a table of values, and it will plot these points for you that are not on the line. So this is something completely different if you just want to make points that aren't on the line. So you can just make points on the graph like 4, 5, 2, 3. But this part is what we're doing for this problem. And we just click the gear icon and the table. Then you can type 7 and you get your answer for what y is immediately, 246. So the nice thing about doing it this way is it does all the math for you. And you won't make a mistake with any of the plugging in the numbers if you have like fractions or decimals or something that's more challenging to work with. All right, and then the slides, the associated slides, they tell us the answer is 246 as well. All righty, so linear functions, they have x and y variables. When they're to the first power, they're a straight line. You can use tables, equations, or graphs to find that, to find what fits the line that fits those points. And if you're unsure about an equation, try plugging in the numbers. All right, so this was number 32, linear functions.